Your interest in testing this calculator. I really appreciate all the feedback that I've received so far, and I'm looking forward to more. Um, Obviously, this calculator is only as good as the information that it provides to its users. So testing is really critical for debugging and checking sort of the calculations against the building code. This testing phase is also really important because I'll be able to get some feedback from the different building code user groups as to what information has been sort of displayed and how it's been displayed in terms of the reports and things like that. And so the adjustments can be made in the calculator to provide the information in more appropriate ways. So as you're going through this for yourselves and testing it, please keep all of that in mind. Like there's lots of possibility with this on how the information can be displayed. The way I have it at the moment is just the way that it made sense for me, but I recognize that might not be the same for everyone. Also, if you have any other ideas about how to build it out even further, I'm definitely interested in hearing that. If you feel like there's something missing from it or something that could be added to it, I'm certainly open to suggestions on trying to build that out. And I have some of my own as well. So I'll probably try and sort of touch on them as we're going through this. So if you have any thoughts on that, I'd be happy to hear your feedback. The calculator that I'm going to send out for testing is going to be limited in some of its abilities for a few different reasons. But one of the limits is going to be that, well, I'll go through them as we get to it, and hopefully it'll make a bit of sense. Basically, I'm just trying to limit it so that people can get a sort of a handle on the way that it's working before I get into sort of more of the more like the complicated logic. And so, this is just a test phase, and yeah, please understand that there'll be hopefully more options coming that will provide a bit more versatility to different users. So yeah, please just jump into it. As I go through some of the examples here, obviously I've already produced a bit of a demo version that I posted to YouTube last week. This video might be a little bit more ad lib, and I'll be going through some of the back-end data on how it sort of applies to the code and some of my thoughts on these different processes. Yeah, I apologize if it's a little bit long-winded. Takes a lot of my brain power to sort of sit down and say all these things out loud. So thanks for your patience. Obviously, I definitely recommend, if you're comfortable with it, toggle through to 1.5 or 2 times speed on YouTube. So I get to the words a little bit quicker. As I said, you're getting a test version of it, but it'll largely look like this. There may be some sort of visuals of it that are different, and just recognize that it is a test version, and there might be like some cells and things that don't fully make sense or aren't completely formatted, but I will be working to clean it all up. So the general premise is that there's a bunch of sheets down here that the user can navigate. There's the instructions and README. These are not finished, and they won't be finished on the test. You can take a look at them if you want, but there's not going to be much information there. I demonstrated the functionality of that in my previous demo, but I haven't really built it out. But yeah, happy to hear any thoughts on that process and the different sorts of information that would be important to have on the instructions and README. But the main landing page, the main starting page is, for most users, is going to be this general tab here. So I was thinking this is going to be called like inputs general 1 or something like that, where we're importing the principal, like the main values that are going into the design related to the site and environmental conditions at the top there, and the building parameters. I go through this in some length in the demo, but basically all the pink cells are user entries. All the blue cells are going to be cells that retrieve a value from the building code or a calculation. Once they turn green, they should be good to sort of move on to the next stage. So basically, if you see some pink up here, it means that you're missing an input. If you see some blue up here, it means that you haven't got the input, so you're not getting the calculation back. And as you move through the calculator, it's going to be an issue because there's no value that the calculator can use. On the left-hand side here, there's also just a little cell that represents the color of the main cell. The reason for that is that once you have this all filled in, if you have to come back and change anything, just so you know where you're sort of navigating to and what you can and cannot change, it'll be illustrated here in pink and blue. To that, I'm also going to lock off all of the cells that you don't need to use, just so that you can't inadvertently enter in information that would disrupt the sort of formulas and calculations of the code. So in some cases, you might try and accidentally, or inadvertently change a cell value, and you'll get a pop-up that says you can't do that. I hope. Anyway, that's how I'm hoping it'll work. I'll just quickly illustrate that I've written in an option for a custom location. So for those of you that happen to be operating or working in jurisdictions where you specify values to designers around snow loads, for example, or any of these environmental loads, there are ways that you can go in and produce a custom location that the calculator will query, and I'll get to that later. There are going to be some limitations, obviously, with any tool. There are definitely limitations with this one. I discuss it at length in another video, which I'll share with you, but this idea of building dimension and how that's going to apply to building code parameters is going to be central to how effective this calculator can be. At the moment, we have the building dimensions here on the landing page, and we only have two options for them. And so essentially that means that the calculator is applying those two values to everything in the rest of the calculations. There may be, and I don't know, as I discussed at length in the other video, but there may be options to provide further, what would be the word, but like provide other opportunities in the calculator where these dimensions can be inputted, which are going to provide more detailed responses to different building forms. Yeah, again, all this is pretty self-explanatory. I'm going to limit the calculator currently so that it's only providing outputs for weight of construction being normal. The weight of construction is a little bit more complicated in terms of the logic that needs to be applied, but my thoughts are that I'll probably write another little calculator that helps a user determine whether their construction is normal or heavyweight construction, so that then they can then have an accurate input in here. At the moment, I was sort of thinking about a few different fields to put in, but I don't really know how this is going to go just yet. So for the intents of the testing, I'm just going to default this at normal. This is going to be an option, continuous or intermittent sheathing continuity. My understanding from the code is that it's not exactly clear, but I think the intention here is that this question that the code is asking specifically relates to the exterior wood sheathing or exterior sheathing of the building. The same concept could be applied to interior brace wall bands, but I don't think that is the intention of the code. And so the reason that I included this sheathing continuity question here on the main landing page is because I think it is a parameter that the intention is to apply it, just generally once to the whole building. Others may have other opinions, and I'd be happy to hear them. If it doesn't apply to the whole building, and we are looking at applying it on a band-by-band basis, then we'd have to move this somewhere in the logic to one of these later pages. Number of wood frame floors is going to remain an option. This is important for a number of different reasons. It helps the calculator determine how many stories for bracing requirements that need to be provided as options in the rest of the pages. The foundation design, you're going to have two options. One is going to be slab on grade, and the other is going to be a basement / crawl space designed as a story for bracing. Again, I'll have another video that outlines sort of the two differences between this one and the next one. Is that I've put it under construction. All these other questions here that the calculator asks are basically a complicated way of understanding whether the basement or crawl space is required to be designed as a story for bracing, or if it's not. And if it's not, it means that there are some forgivenesses in the code that allow you to design cripple walls, for example, or reduce the spacing in your basement of brace wall bands. But my thoughts are that, like, for all the work and questions that go into trying to make that determination, that there's actually not going to be, not going to be too many cases where it actually applies. So the logic is there. I have built it into the calculator, but in terms of testing, before we get to this point, I think I'm just going to lock this all out, so you're not going to need to navigate through that just yet. And you're only going to have two options, so the slab on grade or the basement, designed as a story for bracing. You can check into all this stuff yourself if you like. And just a general comment as you're navigating through the calculator, there is, so whenever there's like a blue square like this, I'm trying to represent them like this. Whenever you see that, it represents a way that the cells can be condensed. So this one here, this table isn't necessary for the users to navigate through. It's helpful for understanding how the calculator logic works, so it's still available for you to see, but you can minimize it here and reduce it. And so that same sort of thought applies on all the pages. If you see a blue square, there's usually going to be a way for you to condense cells. I go through this at length on my previous demo, so I won't cover it here. So I'm going to keep putting through an example. So I've already entered in some information here. So everything's blue or black, and I can see what compliance pathways I have available to me, so I can jump onto the next page. Again, I can apply this filter. I talk about that as well in the other demo. I've already entered in some information here regarding the number of bands. I'm not sure if I have the functionality in at the moment. Say, for example, this is something, obviously it's not very well formatted or anything yet, but if you're interested as you move through here, think about these kind of ideas, because once the logic's written, it's pretty easy to provide this kind of feedback to a user. But say, for example, there are in terms of the rules of 923.13, there are limits on the maximum spacing of bands, and it would be possible in the logic here, and I think I've done it, to actually build this out a bit. So say, for example, we have two bands, but say I have 40 feet between the bands. So I was producing an error notice here. So the maximum spacing for a band in the code is 10.6 meters for stories that are required to be stories for bracing. And so it's possible that to write in this kind of feedback for the user to get some immediate response. So it's easy in this case. It didn't actually apply to my design, which is why it was not coming up. Another thought that I had, sorry, just jumping back to this page. When we talk about building dimension, there may be impacts on how we calculate building dimension, whether or not these additional system considerations are permitted to be used or not. So I would like to have some feedback that comes back to the user in here regarding whether these dimensions should or shouldn't potentially include things like covered decks. Yeah, so again, once everything is green, we can keep progressing. I'll just let you know that if you happen to be navigating sort of like sheet to sheet and coming back here or reusing the same spreadsheet to produce a different design, just keep in mind that if you do, like say for example, we only are currently designing for a roof only, but if I was to come back to this spot and change this to what would now become from a one-story building to a two-story building, and come in here, because I've already applied this filter, the page doesn't automatically update for required inputs. So you would have to come back to unrequired, not required, sorry, and then back to required so that these fields became available to you. So just be cautious as you're sort of testing things and playing around with it, that you want to be, basically my process is that every time I come to a page like this, if I'm not going through the process from the very beginning straight through, that I'm always checking to make sure that the required fields are becoming available to me. But I'm going to go back to change this to 0. So yeah, I'm all good here. I've got a pretty simple building in terms of its size and dimension. I'm going to go through to design and feedback. You see, I've already been playing around with this, so I've got a bit of information entered there. So I'm going to do that same process again. And I'm going to delete all of these. I'm going to put these all in for starters at WSPA. You can, and for some reason I have a hard time with it, but you don't want to do that. I don't know if it's just my mouse or my inabilities. Something that I just wanted to quickly show is like, excuse me, say you're making producing elements of your design for the calculator to review here. Say for whatever reason you're getting a length that is insufficient for your design requirements, and you want to change this reference framing type. Or it could go otherwise. Just say you're trying to change this reference framing type. Say for example you do, and you've already made a selection here. Say for example you change it to from WSPA to GWBB. What's happened here is that you now no longer have this design choice, and so it gets grayed out. So if you had originally selected just GWB-B, you wouldn't have a choice here that would have meant that this was gray, but because you've previously made a selection in that cell, the text is coming up as red. It's just to alert the user that this should be deleted. I don't know if it actually makes any difference to the calculation. I'd have to check that, but that's just something that you might experience as you're moving through here. You will have to sort of review how the impacts of making changes sort of once you've progressed have an effect on previous cells. This one was all pretty straightforward. Again, if you're interested, take a look back at the demo that I did to understand sort of the intention behind this sheet. I will quickly say that yeah, I think there could be merit in, this provides for the overall total bracing in each brace wall band. I really think there could be merit in sort of somehow splitting this up into another sheet for designers where they enter in the length of each brace wall panel in a brace wall band. And that logic is probably going to be pretty simple to devise. And it could just be helpful, another helpful step where designers are putting in that information as they're reviewing, their drawings in combination with the design. If we have that information in the calculator, it will also be really easy to pull it out and export it as a report for builders, so that when their framers are on site and they're looking at a particular brace wall panel in a brace wall band, we'd be able to pull out specific information on the construction requirements. For example, how many, based on the spacing for required anchor bolts, how many anchor bolts are required in that specific brace wall band, brace wall panel. The same thing could apply for nailing requirements for the sill, for example. And there's just a bit of information that could be pulled out that's already existing in the calculator, but we could apply it to very specific brace wall panels. When I was developing this, it's a level of detail that I don't know exactly how helpful it's going to be, but it's certainly a level of detail that could be developed. Entering in the information here for the provided total bracing length in each brace wall band, it doesn't have any further impacts on the calculations. It's purely just for this table. So now we're starting to get into some of the more technical information and reports. And this, for those of you that are reviewing sort of the technical aspects of this calculator, and is it actually producing calculations that are truly reflecting the values that are represented in the code, this is one of the pages that is going to be helpful, which is why I thought it would be most helpful for building officials, because that is, essentially, I guess, part of a plan review. But the idea here is that the designer has entered in the information that is important to them. The calculator has queried the building code and the building code tables, and it is producing that information so that a building official could review it. Now, I've made a couple of notes here, and I'll probably leave them in for the test. But all of these values can be reviewed against the tables in the building code. There is interpolation that takes place for a lot of these. Some of them not. But that's how you, if you are testing this and you're curious about how effective it is, you're going to be thinking about these values in relation to the building code tables, and I'll jump into them a little bit. I've written them up here. So this is the calculations for wind against the calculation method tables. And so the wind ones are represented in 923, 13.7, A and B. These ones, I need to fill it in, but I believe they're C and D for seismic. And so I'll quickly just toggle my screen to what they look like. Okay. So on the left-hand side, on the left-hand side I have the seismic tables. So these are the tables that look like this. So this is table 923, 13.7C. And all these numbers, obviously like a dense set of tables. And you're looking, as you make a design or check a design, in terms of determining the unadjusted length, you're looking in these tables for values to use to determine that. The same could be said for Table A, which relates to wind. It's slightly more simplified, but the same sort of concept applies. The reason that it's slightly more simplified is that the unadjusted minimum total length for wind does not have a factor related to the building length dimension. So there's no variability based on building length dimension, because the forces developed by wind on a building are unaffected by a building length parallel to the bracing. Anyway, that's kind of long-winded, but it's just a simpler table in the end. Whereas for seismic, absolutely, the length of the building parallel to the brace wall band has a massive effect on how much bracing is required in that band. So yeah, these tables are more complicated, but they're all there, obviously. And for those testing it and wanting to see if the values that are coming back are accurate, we can jump into this a little bit. So I'll do that right now. On our design that I'm demoing on the calculator, we have an S max value in the range of, I think it's 1.55. Just double check. Sorry, just jumping back here. Yeah, so we have a S max value of 1.15, sorry. So we would be in this bracket here, right, with an S max value of 1.15. The building that we've designed is only a single story, so it's only the wall supporting the roof, so it's going to be this set of tables here. And I believe I referenced WSPA as the only reference framing type. Changed it. Okay, so single story, walls supporting the roof only. We've got our building dimensions parallel to the band. We've got our reference framing type, and we know our S max value, so we can jump back into the table. Here, we know we're now looking in here, and primarily we're going to be looking at this set of values here. What the calculator is going to do for us is interpolate these values based on our building plan dimension. And so that, if I go over to here, that is what is coming back with our unadjusted length. Now, I should say, in this case, our unadjusted length. And again, we can even look at this in more detail if we're interested to check the calculations. So come through here. We have our table of unadjusted lengths. And this is, again, it's just like back-end information that the calculator is pulling out to help a user verify their calculations. I've made some adjustments to the building code tables that you will find at the end of the calculator, because there are ways to represent the logic of the tables that the calculator can understand. Anyway, and so one of those ways is producing limits on the table. These don't actually exist in the building code table. I guess they're represented, but they don't exist in terms of a value. So these numbers are a little bit different. Anytime I've ever done that in the calculator, I think I've tried to italicize it, just to make reference that there is some, I guess, assumptions going on to make it easier for the calculator to understand. But so let's take example our first line here. As I said, we've got our S max value is in this bracket for our tables. This is our band dimension. It's 10.36 meters, let's say. And we remember that we're using WSPA. And so we're going to go back to the building code. We've got our seismic on the left here. This is our value. Is it 10 point something, I think? Right, so WSPA, we're probably looking for a value between 1.62 and 2.11. So these values here, just take note of them. Right. We have basically 0.66 to, what's the highest one there? 3.08. And our calculator for us is pulling back those values. So we have 0.66 and then all the values up to the point of 3.08. And in terms of our dimension, we are going to be interpolating this set of tables, which is referenced from the BCBC, to a value for a length between 9.1 and 12.2. And that's how we're coming out here at 1.82 meters. So just double checking. In this table, WSPA, so hard to see. I think it says 1.62 and 2.1, so we're somewhere in between there. So I'm assuming that the formula that I've written into the code is accurately interpolating between these two values. Let's go back. As we can see, these only go up to 18.3 meters. And I think I'm correct in assuming that we can build buildings that are larger than 18.3 meters. However, we're going to have to extrapolate our values for building plan dimensions that are beyond that size. And so the calculator does that for us, and it's represented here as well. So this is the uppermost extent. This number is in some part influenced by the overall building plan dimensions that are entered on the original screen. And what the calculator does is provide a reference point that is slightly larger than the uppermost building plan dimension, so that then the calculator that then can produce like an extrapolation or an interpolation beyond the 18.3 meters. The same process happens for the wind tables. So the wind tables are represented pretty similarly. I won't go through the same process here, but basically the calculator is doing exactly the same thing. It is taking the information that we have provided. It's in terms of what story we're on. It is taking the information related to the hourly wind pressure that is based on the inputs and the appendices, and then also our reference framing type, and providing a direct calculation for that. Now, I mean, yeah, I'm going to look at this. I can just do it quickly, I guess, but we've got 1.9 again. The only things that are going to be dependent here are the wind pressure, so we're in this bracket between 0.4 and 0.5, and in WSPA, so if we look at that table, 0.4 and 0.5 is here, we're on the uppermost story, WSPA in 1.9. So that's where that value is coming from. All right, so there's a little bit more information here in terms of the way the calculator is calculating the unadjusted lengths for the tables method. Maybe a bit more information than most users will need, hence why when we were looking at this report, we're just throwing back the actual value. All right, so yeah, you can dig into this number more by going further into the tables. These values here that are represented, these are all considered factors in the building code. And so there's this sort of concept with the lateral bracing subsection that we have these factors that, or this sort of reference house, if you will, that produces, I guess that was probably like the basis for understanding the application of the CSA standard to Part 9 construction, and it became like the reference. And so any parts of your design that match the reference design, you're going to be given a factor of your calculations of 1. All right, so essentially, if the factor is 1, it's going to make no difference on the unadjusted length. Okay, if your proposed design strays in one way or another from the reference house, the code is going to either require you to produce a factor that produces more bracing requirements, or it's going to give you permissions to reduce the bracing requirements. And so the way that that would be represented is if, so this factor is 1, but for example here the factor for wind for roof height in this case with our design is less than 1, and so presumably the roof that we have designed is proportionately smaller than the roof that is part of the reference frame type. And so that can be reflected here. To determine the overall requirements for bracing using the bracing tables calculation, we are taking our unadjusted lengths and we are multiplying it by all of our factors. All right, so this is the total result in the end. This is the unadjusted length that I went through before with the other tables. These are all of our factors that we're applying. As you can see here, like most of ours in this case are 1. We have some forgivenesses that are coming because we're producing a design that is presumably simpler or smaller than the reference type. And then this is our output. The same thing can be applied here to seismic. These factors, we're referencing them against the building code, are the tables after the unadjusted lengths table. So for the seismic, it's going to be table D, and for wind, it is going to be table B. We're only using normal weight constructions, so in this case, our adjustment factor is always going to be 1. It's more complex systems around bracing systems using or building types using heavyweight construction or heavy cladding materials. So this is all to do with the cladding. And we will get to that, but maybe not today. So anyway, we're still on the seismic factors. As you can see here, this is the name of the factors, how it applies, what it means, and then the different numbers that are assigned as factors based on these sort of variables. In some of these, there is interpolation required or permitted. In some of them, it doesn't even matter. But say, for example, we're looking at the number of parallel brace wall bands. This is obviously just going to be direct numbers. And so basically the calculator is taking how many bands you have in a particular direction and querying the code for this information. For something like spacing, interpolation is permitted, and up to a point, obviously. And so the calculator is making interpolation calculations based on the spacing. The same concept and idea applies to the factors for wind. So again, the calculator is taking this information in the code. If you decide to look through the tables that I've included here from the BCBC at the back end here, I've had to make, I don't want to say like adjustments to them. I still think that they're pretty accurately reflecting the intention behind the code here, but some of this kind of content needs to be turned into, to use a calculator, it needs to be turned into a way that a calculator can understand it. So anytime I've made those adjustments, you'll see that certain values will be italicized or something like that. It's just to help the logic of the calculator. But still, when you're reviewing these things, or if you want to check them, you can look at these numbers and then check them against the different options that are available in these two tables. And you can perform your own manual calculations for interpolation, for example, like regarded to the ridge height here, and see if the calculator is getting the right number. as I'm going through this, I'm just making a couple of notes because there are things that are sort of popping out for me as well. I mean, for those that are interested, that little brain moment for me was looking at this K-sheathing factor here. So for example, in this section, so this is related to seismic, I'd originally said at the beginning of this presentation that the sheathing factor, whether it's continuous or intermittent, is something that should apply to the whole building. That was sort of how I understood it to apply. And my reason for that was this here, it says continuously wood sheathed. And so, the way it's been presented to me is that the sheathing factor is to allow for different types of design where people are either, they don't want to install like a wood sheathing all the way around the exterior because they might want to put on like a rigid foam insulation or something like that, and so you're not going to get that same bracing element all the way around the building. But just comparing these two, I don't know if, and this is sort of questions for the code writers, like I don't know if continuously sheathed and intermittently sheathed, if this sheathing factor means something different for, this is for wind, where the K-sheathing factor means something different for wind as it does for bracing. I have simplified them to only one component. The values are the same. You'll notice that, so for continuously wood sheathed for seismic is the same as continuously wood sheathed for wind. So I don't understand, like, and there's some inconsistencies, but overall I think it's pretty well designed. But some of these types of things can make it difficult for code users, and certainly difficult for regulators to understand exactly what things mean. So anyway, that was just a bit of a sidebar. Okay, so I think that pretty much explains this page and what the different values mean. All right, so we've got our unadjusted length, which is based on an interpolation, and then we have all our factors in here based on those other tables in the building code. Sometimes interpolation applies, sometimes it doesn't. And our end result, which is here, is our unadjusted length multiplied by all of these. And that calculation is in the building code. Maybe I'll just quickly go to it. So again, this is like part of the frustration. Like there's so much to wade through in terms of our design. Anyway, so here we're looking at, so just above table C, we're looking at the way to calculate the total bracing length for resistant to seismic. And it gives a little bit of information here that's also reflected in the calculator. But so that last table that I was looking at basically is representing this. Okay, if it turns out that you have a brace wall length that is less than 600 millimeters, then your length is going to be 600 millimeters. But anyway, that table is representing this, and the same thing happens at the top of table A for wind. I think I can move on from this one. In terms of the calculation method, the alternative calculation method, I've definitely received some questions regarding this process, and this is referenced in the notes, but it's linked through the main body of the code. I'm not sure how different jurisdictions are going to approach this. It'd be great to get some clarification from the code writers onto the intention of putting this into the notes and why that happened, or if it is only in the notes. I don't fully understand that, but anyway, I've included the table here so that people can dig into it a little bit for themselves. And the same kind of process applies to the adjusted length that comes through the the tables that I had here. Except that all these values here are sort of produced from a combination of the factors, which I showed before, but then also coefficients that are, I believe they're referenced in the appendix as well. So the same process applies. We're taking a length, and in this one, yeah, I'd have to dig into it a bit, but rambling. So we're multiplying all these factors together to come up with a total length of bracing for a particular band. Now, if you look at the actual numbers that we're using here, we get quite a varied result from the tables, and I don't fully understand why that's happening. I've tried to double check my calculations, and I think they're accurate, obviously, but one thing that definitely does happen is that for our base environmental factors of our hourly wind pressure and our S max, by using the alternative method, we are given an exact value that is found in the appendix. Now this is different and to the way we calculate it with the adjusted lengths, but as you saw before, when we're looking at the tables, we're looking at sort of bracketed values. So when we consider hourly wind pressure, we're looking at a value between, in this case it would be between 0.4 and 0.6. All right, so the code is bracketing our values for hourly wind pressure and S max when we're calculating our adjusted lengths. So this, the adjusted lengths using the alternative method, among other things that I don't understand, provides, a more, like a higher fidelity, if you like, in terms of the way that the lengths are calculated. And again, like all these values here can be referenced back to, like if they're an exposure, sorry, if they're like a K factor, like represented here, they can be referenced back to the K factor tables that were that I was showing before. All right, so there's some of them for wind and some of them for seismic, but then there are these other coefficients that are referenced in the appendix, or the notes, I should say. And so the calculator has another table back here which references these coefficients, and then in some cases it uses interpolation, in some cases it's a direct number. And I've tried to base that as best as I can based on the information that's given in the code. I'll just jump back one because so here we are. This adjusted lengths for the tables. That's not what I wanted, sorry. Sorry. I'm going to jump ahead to this one called comparison. This comparison is a more in-depth comparison for the designer or building official to compare the calculation method of the tables against the calculation method of the alternative process. And basically it outlines when we're using the calculation method, we calculate for wind, and then we calculate for seismic, and then we determine what is the most restrictive element that we're designing for. And in this case, with our example, it is seismic. For the alternative, we do the same thing. We calculate for wind and seismic, and then we select the most restrictive. Now, this option to use the alternative method is in part required in some cases. If we go back to our tables and we look at, again, we're looking at table, what is this one? C. Let's look at table C for seismic. When we start to see values here that represent DR, it means that they're saying that at least the code writers are saying that design, I think it says design is required, and then it points you to the alternative way of calculating this value. And they become more apparent and more widespread, these references, as the S-max value increases. Okay, so as the S-max value is increasing here, we're seeing more of these. And certainly as we get to the higher S-max values and the lower supporting floors, we certainly start to see a lot more of DR coming through in the tables. Right, so even here, this is our highest S-max value that we can design for in Part 9. We have 3 stories of required bracing design, and even here where we have a wood-based panel, WSP-A, the code is pointing us that, okay, we're going to have to use the alternative method to determine the bracing length in this scenario. Now to get that through into the calculator here, let's see if I can use an example so you can see it coming through. So I'm back here at the Design and Feedback tab. We had selected WSP-A, and so I'm going to change this so you see the use case. With me here. This is just to illustrate something. So I'm now going in to change the site class, and I'm going to change it to unknown, and this is going to change the S-max value. It's going to elevate it. So we just went up a bracket there. I'm not sure if you noticed that, but we were on C before. Right. Change it to unknown. We went up here. Going back to design and feedback. For GWB-A with a building plan dimension of this length, this values for the calculation method and now coming back as essentially inconclusive, right? But the alternative method is still calculating. Okay, and the reason for this, if we look at our adjusted lengths table, our unadjusted lengths table, right, these values are coming back as DR, all right, so design required. If I look at, here we are, so we're in this, no, 1.55, right, so this is our bracket. We are on the uppermost story, we're designing walls supporting the roof only. The measurement of our building, I think, was between 9 and 10 meters. We picked GWB-A, and so we're getting these DR values here coming through in our calculation and in the calculation method, and that's why it's saying that we cannot design to the calculation method. While I'm here, I'll also just point out that this number in a bracket here relates to a unadjusted length that we can use if we double up an interior drywall based panel as 2 GWB-As. So my understanding is that means that if there's one GWB-A on one side of the wall and another one on the other side of the wall, then you can provide this calculation for the unadjusted length of 4.7 meters. There also is a generalized permission in the code that you can halve the unadjusted lengths. So these ones here, for example,